Okay, so let's open up your notes to the second page where it says 5.2 Rules of Exponents, day number 1. Okay, let's discover the first rule that we're going to learn. It says, let us multiply two powers that have the same base. So for example, and this is not an example in your notes yet, we're just kind of exploring one of the first rules. So say I'm taking a to the 5th power times a to the 2nd power. Well, let's think about what that means. We know a to the 5th power means a times a times a times a times a, 5 a's. And a to the 2nd power means a times a, or 2 a's. So if I'm taking 5 a's times 2 a's and I'm multiplying that all together, well, essentially you can just count how many a's there are, and you can see that there are 7 a's. So 5 factors here, 2 factors here, all together makes 7 factors. So therefore, the answer, or a simplified version of a to the 5th times a to the 2nd, would be a to the 7th, which you can see simply comes from adding simply adding the 5 and the 2 together. Okay, so that's how our first rule works. Okay, again, here's the rule. So it's called the product of powers property. Not that you need to memorize the name by any means, but that's just what it's called. So the important thing to notice on this is that when you're multiplying the powers, they have to have the same base in order to add their exponents. So the base could not be different in order for this to work. They have to be the same base. Okay, so here is the rule itself. A to the m times a to the n would equal a to the m plus n. So since the base is a on both of those, we can just add their exponents. Okay, which with one more example, 5 to the 3rd times 5 to the 4th. Well, if I wanted to simplify that, all I would have to do would be add those. Since the base is the same, I can just add the exponents. So keep the base 5. Remember, you're not actually multiplying those bases. Keep the base 5. Just add the 3 and the 4 together, which would make 7. Okay, so let's do the examples in your notes now. Okay, so the first set of examples, the first example that's in your notes says 2 to the 3rd times 2 to the 4th. Okay, you'll notice the base is the same. The base is 2 on both of these. So you keep the base 2, and you just add the exponents of 3 and 4 together, which would make 2 to the 7th power. Okay, of course you could go ahead and calculate 2 to the 7th power, but right now we're just practicing using the rule and knowing what it wants us to do with the exponents. Okay, now here is the next problem. So we have negative 3 to the 7th times negative 3 to the 2nd. Go ahead and take a second and think about that one. Think about what the answer might be. Okay, so since the base is negative 3, we keep the base the same, and we just go ahead and add those exponents. So we keep the negative 3, do 7 plus 2, which would make negative 3 to the 9th power. Okay, here's the third example. X to the 5th plus x to the 3rd. Well, again, the base is the same. This time it's a variable instead of a number, but we keep that base x and just add the 5 and the 3 together, which would make 8x to the 8th power. Okay, again, notice on all 3 of those examples, the base is the same on the 2 exponents that we're multiplying. So if the base is the same, we can just add the exponents. Okay, so I want you to add one more example in this box. Write it as example number 4. So go ahead and take a second to write this down. So 2 to the 3rd times 3 to the 5th. All right, now think about this one. Can we apply the rule that we just learned? Well, if you're thinking no, you're right, because look at those bases. The base of the first one is 2. The base of the second one is 3. So they have 2 different bases, so we're not going to be able to add those exponents. So not possible because different bases. So you can go ahead and write this. Make sure you have all this copied down in your notes. Okay, so that is the first rule. So the rule, when we have the same base and they're being multiplied, we add the exponents. Okay, so let's explore another rule. This rule, it has to do with when we're dividing two powers that have the same base. Okay, so here's an example, not in your notes, just for you to follow. So if we think about what a to the 6th and a to the 2nd mean, we know a to the 6th means there are 6 a's being multiplied, and a to the 2nd means there are 2 a's being multiplied. Now think about what happens when you're dividing. Since we're dividing, you know when you divide something by itself, it would just make 1. So I've got 2 sets of a's here on the bottom. If I do a divided by a, that would make 1, as would this a and this a. So I can show that by, first here's the 6 factors and the 2 factors. So these a's would cancel each other out, again, because a divided by a just makes 1. Then we can cross off these a's as well. A divided by a would also be 1. So you'll see what we're left with is just these 4 a's that are up here on top. So it would be a times a would be the simplified version. Well, what's a times a times a times a? Well, that would be a to the 4th. So if you think about how we could get the 4, we'll notice that the base again was the same. The base was a, so we can keep that a. All we had to do was subtract those exponents. So subtract 6 minus 2, and that gave me 4. All right, so that rule, that's the second rule. It's called the division of powers property. Again, it says if we're dividing powers with the same base, we're going to subtract the exponents of the denominator from the exponent of the numerator. Okay, and here's what the rule looks like. Again, notice the base is the same. If there's division involved, we will subtract the exponents. Now it says where a does not equal 0, that means we can't have 0 as a base. That doesn't apply to this rule. Okay, so one more example before we do our notes. If we have 4 to the 5th divided by 4 to the 2nd, they have the same base of 4, so I keep the base of 4, and then I subtract those exponents. So 5 minus 2 would make 4 to the 3rd power. All right, so let's do the examples that are in your notes. Okay, so you're looking at the second box in those notes. Okay, so the first one we have here is 7 to the 5th power divided by 7 to the 3rd power. Okay, if we apply our rule, we keep the base of 7, and then we just subtract those exponents. So subtract the numerator minus the denominator. So subtract 5 minus 3, which would make 7 to the 2nd power. Okay, again, we didn't actually divide the base, we just kept the base the same. That's the important part, is remember the base is never changing when you're simplifying exponents. Okay, here's our second example. You'll see it's negative 8 to the 2nd power over just negative 8. Well, let's think about it. What exponent would be right here with this negative 8? Well, there's just one negative 8, so that's like saying to the 1st power. So when I'm simplifying this, I'm taking the 2 minus the 1 as your exponents. So it's negative 8 as your base, and then 2 minus 1 would just make 1 for an exponent. But if something's to the 1st power, we don't need to write the 1, so we're allowed to just write negative 8. Okay, so you could have just negative 8. If you put to the 1st power, it would mean the same thing. Okay, here's another example. X to the 8th over x to the 2nd. Go ahead and take a second and think about what that answer would be. Well, we would want to subtract those exponents. Again, since the base is the same, the base is x, so I keep x as the base. I subtract the 8 minus 2. And I end up with 6 as my exponent. So x to the 6th power. Okay, now again, I do want you to add one more example. So add this into that middle box for day 1. So go ahead and write a to the 5th over b to the 4th. Okay, now as you're writing, think about, how do I simplify this one? Okay, are you noticing that the bases are not the same on this one? We have a on top as a base, and b is the base on the bottom. So since those bases are not the same, we cannot simplify. We won't be able to subtract these exponents. Okay, so again, it's not possible because they're different bases. So I hope you've noticed that so far with all these rules, that the rules only apply if those bases are the same. So if we're dividing, we're subtracting exponents. And in the previous example, when we were multiplying, we were adding the exponents. Okay, so we have one more rule to learn about. Okay, so let's think about what this problem looks like. This part, again, is not in your notes. So think if we're doing 6 squared and then we're taking that to the third power. Well, we know what 6 squared means. That means 6 times 6. And then if we have that to the third power, that means we're taking 6 times 6 3 times. So here's one 6 times 6. Here's a second 6 times 6. Here's a third 6 times 6. So altogether, I have 3 sets of 6 times 6. Or if we count it up, we got 1, 2, 3, 4, 5, 6 sixes. So that would be 6 to the 6th power. So let's think about that. How could I get 6 from the 2 and 3? Well, you guessed it. We would just multiply those together. 2 times 3 makes 6 for the exponents. Okay, so when those exponents are side by side, we will just multiply them to get the answer. Okay, so this is called raising a power to a power. So to raise a power to a power, you simply multiply the exponents. Okay, so kind of think about it like, when we have something in parentheses with another number on the outside of the parentheses. Remember how that always means multiply? That kind of helps me remember that, oh, I just need to multiply those exponents. Again, notice base does not change at all. We just multiply the m and the n together. Okay, so here's one more example before we do the ones in our notes. So 5 to the 3rd to the 4th power, well, I would just multiply the 3 and the 4 together. So I'm going to take 5, keep the 5, and the 3 times 4 would make 12. So it'd be 5 to the 12th power. All right, so we got 3 more examples in our notes to do. Okay, the first example says 4 to the 3rd to the 5th power. So again, keep that base of 4 and then just multiply those exponents together. So 3 times 5 makes 15. So it's 4 to the 15th power. All right, here's the second example. Think about this one for a moment. Okay, so we just keep that base of x, and then we just multiply the 7 and 3 together to get x to the 21st power. Okay, now go ahead and try the very last example, a to the 4th to the 2nd power. Think about what this one is as well. All right, so again, we keep the base a, and then we just multiply 4 times 2 to get a to the 8th power. All right, so those are your notes for today, and now you're going to do a little bit of practice of this before you move on to your homework.